Up to this point, we have looked at some different types of slope formulas. We've looked at the formula just for slope. Remember, m equals y2 minus y1 over x2 minus x1. We've thought about vertical and horizontal lines using Hoy and Bucks. We have looked at y equals mx plus b. Remember, slope intercept form in depth. But there's one more formula that I do want to talk about that talks about slope specifically, and that is the point slope formula. Now you're like, why would I need a point and a slope in the same? I have slope intercept. Remember that that intercept only helps us if we have a y-intercept. We're not always given just the y-intercept. Sometimes we're just given a random point and we have a slope, and we need to get that into point slope form. The reason being that it's common for the, any type of an assessment to show you point slope form and then ask you, okay, what form is this in? And then further ask you to get it back into slope intercept form. So understanding what the formula is showing you will help you understand where to go next. So our point slope formula is y minus y sub 1. Now remember that y sub 1 is just a name for the y value of the coordinate you've been given, equals m, well there's my slope, parentheses x minus the x sub 1 represents the x of the coordinate you've been given. And then we close up those parentheses. So we're going to practice writing an equation when we've been given the slope in one point, and we're going to practice writing it in point slope form. So let's think about that equation. It starts with y minus, and then we need to insert the value of the y that we've been given. We've been given 3, so y minus 3 equals the m, we've been given the m, that's the slope, 2/3, parentheses, x minus the x value we've been given, which is 2. That is point slope form. Let's try the next one. I'm going to say, well, y minus, what's my y value? -1. Y minus -1. And I'm going to write it that way first because sometimes that's how you'll see it when you're using technology. Be really careful. This formula has negatives in it. You know that y minus a negative is plus a positive, and we're going to rewrite that in a second. Equals my m, my slope, -2, open parentheses, x minus the x I've been given, which is 4. Now if we want to clean this up and make it look neater, we would just say, well, this is actually y minus negative is plus 1, so y plus 1 equals -2 and then x minus 4. That's just to simplify it and make the problem look very clean. Okay, y, we're going to start with y minus, what do we have? 0 equals my slope of -1 times x minus -2. If I was just to plug it in as is. Let's clean this up. Y minus 0, no, we just write y, right? We keep the -1, we're still in our point slope form. X, we don't write minus and negative, we write plus 2. So x plus 2. That is the very nice and neat version, the simplified version of the point slope form. One more. Y minus my y value given is 5 equals my slope of m in parentheses x minus 0. Well, often they're not going to have x minus 0. So what this is going to look like is y minus 5 equals, well, x minus 0 is just x. So they would actually write that as y minus 5 equals 4x. So thinking about how can I get from one form to the next. Next we have identify the slope in point form from an equation written in point slope form. So they've already written it for us, y plus 2 equals -1/3 x minus 9. I'm going to go ahead and write the formula right underneath it. Remember, y minus y sub 1 equals m times x minus x sub 1. What's my slope? Yeah, my slope is the -1/3, okay? I need my point, so I'm looking for that xy. The x minus my x minus 9, so there's my x. And I need my y minus y. but this is plus 2. Remember, this should be a subtraction, so if it needs a subtraction, it would be minus a negative, would be the same as plus 2. So that means that my value of y is actually negative 2. Let's take a look at another one. If I was to write the formula directly under it so I could just kind of analyze it a little closer, I would write y minus y sub 1 equals m times x minus x sub 1. Now I need the slope. The slope is the m, so the slope would be 5/2. I need that point, that xy. I'm going to look here. Minus my x1 plus 2. Plus 2. That means that's actually minus negative 2, right? So my x is negative 2. My y sub 1 should be subtract. That is subtract, so that is 1. So this would be my point of negative 2, 1. Okay, so next up we want to graph this information. We've been given our equation here, and we notice that this looks like it's in point slope form, right? If I was to write the formula underneath of it, that'd be y minus y sub 1 equals m times x minus x sub 1. Well, my slope is that negative. What number is that? Just a negative? No, there's an imaginary number there, right? That magical number 1. So my slope is negative 1. The point I've been given. Well, my x sub 1 minus 4, yep, that'd be a 4. My y sub 1, well, it says plus 0. Well, it doesn't matter if it's negative or positive, it's 0, 0. So from here, I would plot the point 4. So 1, 2, 3, 4, 0 is right here. And then think about your slope, negative 1. So negative 1, well, that could be a fraction of down 1 forward, right? Negative, down negative. Remember, this should be going downhill. Or we could have thought, well, I could go up and back. So thinking about your slope, I need to have a downhill slope. I'm going to use a straight edge to create that line. All right, so there's my line. It is negative. It is going through 4, 0. I want you to pause the video and try the next one on your own. All right, so if you wrote that formula underneath, that helps you think about your positives and negatives, because that's the part that's the most complex and just going to really just kind of throw you off when it comes to point slope form. So our slope here is negative 3. Our point is 2, negative 5. So I have plotted 2, negative 5 down here, and then my slope of negative 3. So remember, a slope of negative 3 could mean down 3, forward 1, or it could mean up 3, back 1. So think about slope, negative 1, either the numerator or the denominator is negative, but both can't be, because if they're both negative, it makes a positive. So let's just think back and let's look again at our formula real quick at the top of our page. So the point slope formula is really to help us when we don't have an intercept. Could you use slope intercept form to go find the intercept? Absolutely. But it's always nice to have one extra formula that we can just kind of put in our back pocket and use it when we need it. So point slope is what you will use when you don't have the y-intercept, but you do have a point and you do have a slope.